So in the last video, we took a look at groups in Houdini, and in this video, we're tackling attributes. Attributes are in a lot of ways very similar to groups, but offer us a lot more flexibility down the road. To follow along, please open the starter hip file that you can find inside the scene files download. First of all, I want to do a quick recap on groups. We had our first case of a node that does not directly change the geometry of our object, but simply attaches a bit of data to it. And that data can travel down our geostream, down to a node where this data is actually used. In this case, pinning all the root points of all hairs, of all copies, and in this case, making them stick on this torus like this. But we also found a limitation of groups. A point or a face can either be inside a group or not, and that's it. There's no way we can have gradual changes with groups. And if we, for example, use groups to create a dust on an object, we get a very visible boundary at the edges of a group. So as promised in the last video, attributes will be the solution for that problem. Let's quickly build a simple example and then talk about what attributes do differently. This might be a lot to take in at once, but we'll cover all these steps involved in more detail later. So again, we're starting out with our AHTYA, and we want to use a scatter node in the end, and in between we have to do some stuff with attributes. So first things first, I'm going to take a look at my scatter node, and we're going to look for attributes in my parameter fields right here, or the keyword attribute. And I get that here with a density attribute. And this seems like it can be used to control, well, the density of our scattering on our object. So let's first of all enable this. Now a node throws an error. The error is because there isn't a density attribute on my geometry here. So let's create the density attribute. For this, I can go to the attribute tab here and take a look at all the nodes that I have in here. Or I can search for the right node, and the right node that I want to use in this case is the mask by feature node like this. There's a few special variations of this, for example one for height fields. We want just the standard mask by feature node right here. Let's drop this down and wire it in. Our node down here is still complaining. Why is it complaining? Well, this mask by feature creates an attribute that is called mask, not density like this node wants to. So let's name it density. And once we enter the right name, our setup here is working. And we get very nice and gradual changes from the top of our surface down to the bottom. So why is this working so well? Attributes take the system from groups and add one more property. And that property is data types. Groups store data that is very much binary. A point or edge or face is either inside the group or not. Our attribute here instead uses float data, so a number with a decimal point. That means that one area can contain, for example, 50% or 10% or 30% or 63% or so on of the number of maximum points that I'm scattering. And the mask by feature node creates a very nice gradient of values that we can later use in our scatter node. So whenever you want gradual changes in the effect of one node, you need to look at attributes in Houdini. Let's take a look at the basic properties each attribute has next, and we can get an easy overview over those by using an attribute create node like this one here. So first of all, we have a name, and like with groups, that name is of course mandatory so that nodes downstream can grab the right data. Next we have the attribute class, which is pretty much the same as the group type, so which part of our geometry the attribute will be stored on. There are a few slight differences compared to groups here, which we cover in the next video. And finally we have the new feature, we have data types. For now, we've only worked with floats, so numbers with a decimal point, and over the next round of videos we mostly stick with floats and ignore the other options. However, later on we will do look at other options here, and these are mainly integers, so numbers without a decimal point, vectors, so a position or a direction in 3D space, and strings, which are essentially just pieces of text. Now you're probably aching to start actually using attributes, and we'll get to that in a second. However, there are still two little topics we should look at first. First of all, we should know that attributes are pretty much everywhere in Houdini, and pretty much everything we do in Houdini will create or modify attributes on our geometry. For example, if we take a look at a very simple object inside Houdini, if we take a look at a box, if we take a look at its info panel right here, we can already see one attribute on there, and this is the P attribute. And what is the P attribute? The P attribute simply stores the position of each point in space. And if there was no P attribute, well, we wouldn't see any box because it simply would not have a shape in 3D space. And pretty much all data we have usually on 3D meshes is represented by attributes in Houdini. In this example, I'm starting out with a sphere and then adding normals and vertex colors and a texture and then even a simple shader using a UV quickshade node. And if we take a look at the info panel again, we see all these properties represented in here by attributes as well. So of course we again have a P attribute. We also have a attribute called CD for a color. Then we have a shop material path attribute, which is the path to our shader. Then we have an N attribute, which is a normal. And then we have a UV attribute, which are our UV or texture coordinates. And if we take, for example, a look at something like the rubber toy, we can also in here find a lot of these same attributes. Now, apart from attributes that visibly change the appearance of our object, we do have a very similar problem as with groups. Attributes aren't just very visible, which makes tweaking and debugging them somewhat difficult. And luckily for us, Houdini offers a range of ways to inspect or visualize attributes. So let's quickly take a look at them. And in here, I'm again using the mask by feature node to create an attribute called mask on my geometry. So first of all, we have the info panel. We already know this. And here is our mask attribute. But there's also a more detailed version of the info panel, and that's the geometry spreadsheet. And we can find this right here. This may look a bit frightening at first glance. Spreadsheets have invaded our graphics program, but this can give us an overview over pretty much everything Houdini knows about our geometry. On top, we have tabs for each attribute class, each type of geometry that attributes can exist on. And for example, with a mask node selected and going into the points tab, we can see our mask attribute right here. And we can even sort by clicking on this mask attribute and see that this mask attribute is in a range from 0 to 1. This all may still look a bit foreign to you at this point, but using it will quickly become second nature once we start tackling more complex scenes. Let's jump back to a scene view. Because what the geo spreadsheet can't show us though is how attribute values are distributed. For this we need visualizers. And sometimes nodes like this mask by feature node do offer a visualizer themselves. If we jump into the handles tool, we can see a sort of heat map of the value distribution right here. But not all nodes do. So for this we sometimes have to build our own visualizers. And there are two ways to do so. So first of all, a very quick and hacky way that's also maybe more beginner friendly is simply using a color node. Drop down a color node and wire this in. We can choose in here a ramp from attribute. And if we click on this and select our mask attribute right here, we get the same distribution as we saw on a mask by feature. And we can even change this, for example, to infrared to get the same kind of heat map that we saw before. Now, this is simply creating a color attribute. If we do want to create an actual visualizer, there's a different way. I'm going to delete this node right here and I'm going to drop down simply a null. This is not mandatory. It just makes the scene a bit more neat. And all I'm going to do here is click on the info panel. I have here all my attributes selected and then I'm going to click on the mask attribute right here. And now as you can see, I get the same kind of preview. Now this kind of preview lives in this bar right here at the right side of my 3D view. This is the visualizer bar and all my custom visualizers live down here in this icon that looks a bit like a Google Maps icon. So I can toggle this on and off to get my preview or not. And I can also right click on this. I have already a few attributes in here set up. Here's my mask. I can enable or disable it. And I can also click on this little pen icon to get all the different options to tweak my attribute, which might be a bit frightening. So this is why you may use a color node if this looks a bit overcomplicated to you. Now, with this done, let's finally look at some use cases. Let's first of all rebuild our scatter setup from before and let's take a look at it in a bit more detail. Again, I'm going to start out with a rubber toy and then I'm going to drop down my scatter node and maybe on my rubber toy to make this all a bit easier, let's uncheck Add Shader and then wire it a scatter node. And again, in a scatter node, I want to turn off the relax iterations and up the total count a whole lot to 100,000. So again, to control this by an attribute, I'm first going to search my parameters here for the keyword attribute. And again, I'm going to find this here. This is our first step done. Then I'm going to think about what things I want to achieve with my attribute. In this case, I want a gradient from the top of my object down to the bottom. And maybe through tutorials or experimentation or reading the documentation, I'm going to find the mask by feature node. So let's wire this in. Then on the mask by feature node, I have to match up some stuff. So first of all, I want to take a look at the attribute and name that I want to match. Our scatter node here tells us that this name should be density, so this should be matched here as well. And at this point, this is working. If this wasn't the case, I would have to check the different properties of my attribute apart from the name so that those also match up. So this is the attribute class, on which part of the geometry our data is, and which data type the data is. For now, let's simply take a look at what we can see in the info panel. So a density attribute is on point level, so this is a point attribute, and it is also a float attribute. Now, for the scatter node down here, it doesn't actually matter if this is on points or perimeters or vertices, so this is something that we don't have to take into account here. And the data type is already the correct data type because this density is just a linear value. We have just a single slider in here, so we wouldn't need, for example, an integer or vector or a string in this case. So we're done here. Let's take a look at another example. For this, maybe I want to drop down a grid. Let's maybe make the size 1 by 1. And let's try to control a poly extrude node. Let's wire this in. Again, same strategy as before. I'm going to search the parameters on my poly extrude node for a keyword called attribute. And in this case, I'm going to find it here under local control. Under local control, I find the local attributes tab. And what I can see right here is that this mimics the 4 sliders that I have up here: the distance scale, the insert scale, the twist scale, and the division scale. So these probably are ways to control these sliders up here with attributes. So let's say we first of all want to control the distance. Let's give it first of all a distance. Let's extrude it up a bit. Let's maybe set this to individual elements and let's give it a bit of insetting. And now let's activate the distance scale on our attribute. No, right now nothing's happening because we don't have an attribute yet. And let's maybe imagine that we want to control the distance that we want to extrude by a noise, for example. So let's search for attrib and noise. We get an attribute noise node with a bunch of presets right here. We just want the default attribute noise. Let's wire this in. Right now, our geometry is just getting colorful. Why is it getting colorful? We're setting the CD attribute, and if you remember from before, CD stands for color inside Houdini. So to make this work with a poly extrude node, we have to match these 3 properties up here. So first of all, our name, this is what our poly extrude node tells us. This is a C scale, so let's change this. Now color is gone, but nothing else happened. Then we have the data type. Right now this is set to vector, but if we take a look at what we want to control in here, this is just a simple slider, so this should be a float. And then finally, if you take a look at what the poly extrude node does, is it extrudes up every face, and right now attribute is on point. So we have to change this to primitives, which are faces in Houdini, and now we can see a noise appearing on a poly extrude. And now I can go in and change the settings and maybe even go down to animation and animate my noise. And now I have a very interesting noisy animation on my object. Now in both of these cases, our node gave us a little menu telling us at least a little bit about the attrib that the node expects. In this case, this Z-scale attrib. There is, however, a second way nodes use attributes that's a bit harder to learn for beginners. So let's quickly build one setup here and then talk about what we did here. So let's move those to the side. And in this case, I want to use the copy to points node. And let's maybe drive this first of all with a sphere. Let's wire this in, and then also a grid. Wire this in. Let's zoom out a bit. And this is the geometry that I want to control. And what I want to do here is I want to change, again with a noise, the scale of each one of those spheres. So let's take a look at the copy to points node first. And again, I would search for the attribute keyword in here, and we do have some in here, but these are just the attributes that are going to be written to the geometry that we're passing to this node. These are not attributes that we use for controlling the behavior of the node, and we can also get an idea by hovering over the attribute keyword right here, telling us what this parameter does. So we don't have a clear way to control stuff with attributes here. So what are we going to do instead? Instead, we're going to, again, use an attribute noise, because that's what we want to use for controlling our scale in the end. That's why I add this in. And in this case, again, we're controlling the scale. So this would likely be a float. This should be on point level because this node is copied to points. So this is a no-brainer. But we have that name, and the name I do have to enter here is called pscale. And once I do, now I get the expected effect, or the effect that I want. I got varying scales on my objects in here. So why did an attribute called pscale suddenly change the scale of our copies? The reason is that each area of Houdini, so whether we're modeling or rigging stuff or simulating stuff, has a small list of special attributes that some nodes look out for. And if such an attribute exists, they simply use it without us having to enable anything. If you're an experienced Houdini user, this can make building your node graphs a bit faster. If you're a beginner though, this does take some time to get used to. To make things a bit easier, I've given you a list of important attributes to keep an eye on, and along with their respective data type and class. So these are the P and UV and CD attribute that we already know. And then this is new, we also have pscale for scaling, or the size of stuff. Now, to finish our section on attributes, let's quickly get a final overview on how we can edit the different properties of attributes like we already did with groups. So again, starting out with a rubber toy and creating a mask attribute on here. And I still got my visualizer down here enabled, which is great in this case. If I want to, for example, change the name of my attribute, I can do so with an attribute rename node, for example, renaming this to dust. If I want to have my attribute on a different type of geometry, I can use an attribute promote, like with groups. So in this case, promoting this to primitives or faces. If I want to change the value range on my attribute, I can have a whole range of nodes. For example, one of the common ones is the attribute remap node, where I can, for example, use this ramp down here to make the distribution more harder or softer. And if I want to get rid of an attribute, I can use the attribute delete node. And also, if I do change my geometry so drastically, for example, converting this to a volume and back to polygons, that my attribute is gone, I can use an attribute transfer node to get my attribute back. And if I want to change my attribute data type, I could do so using an attribute cast node, for example, turning this into an integer. However, we are going to look at better ways to do this later down the road, so I sort of grayed it out here. So this is it. These are attributes in Houdini. And again, this is a pretty unusual and complicated topic if you're just starting out, and it's completely okay to feel a bit overwhelmed at this point. Over the next round of videos, we'll ease into using attributes in our setups with pretty simple use cases and slowly ramp up the complexity. Also keep in mind that you can always come back to this overview whenever you need a refresh. But until next time, it's cheers and goodbye.